Hello and welcome to another IB Math Speedrun with me, Vince, and in this one we're going to be going through the reciprocal trigonometric function. So let's jump right in. So we already know that we have three trigonometric functions, which are sine, cosine, and tangent. And we actually have equivalent functions for the reciprocals of these. So we call these three functions the cosecant, the secant, and the cotangent. So the cosecant is equal to 1 over the sine of that angle. The secant is equal to 1 over the cosine of that angle, and the cotangent is equal to 1 over the tangent of that angle. And so yeah, we can pretty easily remember these by just looking at the third letter, so sine, cosine, tangent, and it's 1 over that. So these three functions also follow the signs of their previous functions. So if we draw this again, all will be positive here, sine only, tangent only, and cosine only will be positive here. And this also follows. So only the cosecant will be positive here, only the cotangent will be here, and only the secant here. Knowing that, let's jump into some problems. So I'm going to do the odd ones, just the ones starting from the first one. And we have first, evaluate secant of pi over 6 minus cotangent of pi over 3. So secant of pi over 6 minus cotangent of pi over 3. So we have secant of pi over 6 minus cotangent of pi over 3. And so we know this is 1 over the cosine of pi over 6 minus 1 over the tangent of pi over 3. And if you memorize these values, you'll know that this is equal to 1 over root 3 over 2 minus 1 over tan pi over 3 is equal to root 3. So we have 2 over root 3 minus 1 over root 3. So this should simply be equal to 1 over root 3, which is equal to root 3 over 3 if you rationalize the denominator. Oops, sorry, I'm covering that. It is equal to root 3 over 3 if you rationalize the denominator. Yeah, next question. So we need to simplify each of the following expressions to give a single trigonometric function. And the first one we have is cosine theta times tan theta. And it's pretty easy to simplify this. What we need to remember is that tan theta is actually equal to sine theta over cosine theta, since it's equal to y over x. So we actually have cosine theta being multiplied by sine theta over cosine theta, which is equal to simply sine theta. So cosine theta times tan theta is equal to sine theta. Next, we have cosecant theta times tan theta. Well, we know the cosecant is equal to 1 over sine theta. And so if we have 1 over sine theta times sine theta over cosine theta, we're simply left with 1 over cosine theta, which is equal to secant theta. So that is a single function. So finally, we have tangent theta times cotangent theta over sine theta. And the thing is, these two cancel out, because this is tangent times 1 over tangent, so this should simply be 1. So this is 1 over sine theta, which is equal to cosecant theta. So that is it. Okay, finally, on to our last question. We know that, where'd it go? We know that given that cosecant theta is equal to 13 over 5 and pi over 2 is less than theta, it's less than pi, find the values of cosine theta and cotangent theta. Okay, so we have cosecant theta is equal to 13 over 5. So 1 over sine theta is equal to 13 over 5, so sine theta is equal to 5 over 13, and so theta must be equal, well, we're working in radians, so change the calculator. So sine minus 1, 5 over 13 is equal to around 0.39 radians, but there's a catch. This is actually in the second quadrant, since we're saying theta is between pi over 2 and pi, so we need to subtract this value from pi. So our actual value for theta is equal to 2.75. So now we need to find the values of cosine theta, tan theta, and cosine theta and cotangent theta. So cosine theta is simply cosine of this, which is equal to negative 0.923, and cotangent of theta, if I inverse cosine that, cotangent is 1 over the tangent. So first let's get the tangent of this, and we put 1 over the tangent. It's funky. So we get 1 over that, and so the cotangent should be equal to negative 2.4. Yeah. So that is all for today. I hope you enjoyed, and I hope to see you in the next speedrun. See you then.